Okay guys, let's get into these lifters. So like I said in the previous video, the lifters don't really go bad, with the exception of just wear on the lifter body itself. So the sides of the lifter here, and then the top where the cam actually rides on it, those can get worn out. But in general, you know, a ticky lifter, or at least when you're rebuilding a head like this, and generally they're not really bad. All they are is dirty, and the reason that they start ticking is because there's a little check valve inside that sits on it's like a little ball valve basically, and it sits on a seat. And if that ball or that seat get dirty with you know, like varnish from, you know, the cooking the oil in there and stuff, it won't seat properly, and then it won't hold pressure in the valve. It won't hold oil pressure. So basically you just need to get all those components clean, and then the lifter will work again. So let me show you kind of the components inside a lifter here. Hopefully I can get this close enough where you guys can kind of see. Okay, so this is an intake lifter. This is the lifter body, and then inside the lifter body there's the lifter itself, and then inside the lifter itself is this check valve assembly. So there's this little guy here, and this fits inside the lifter body, and it has a little check valve assembly in it, which consists of this little ball bearing, this tiny little spring, really tiny spring, don't want to lose those, this little clip that captures the check valve assembly, and then this spring that goes into the lifter body and basically gives the lifter a little bit of spring pressure to help it pump itself up. So those are the components that we need to clean basically, and how I'm going to do that is I have 3 little dishes here. So I have degreaser, just some soapy water, and then I'm using this chem dip. So what this is a varnish remover, carburetor cleaner or whatever. This is Berryman's. Comes in a gallon jug. It's like 30 bucks. It'll probably last you forever. So what I'm going to do is I'm going to take these really tiny components and I'm going to degrease them and wash them off with soapy water, and then I'm going to soak them in the varnish remover for probably a couple hours at least. The main bodies I'm going to degrease separately and probably drop them right in the can. These cans come with basically a little strainer basket, so you can drop parts right into the can basically. And this stuff works really good, and it'll clean that stuff right up. So I'm going to put this stuff in here, get it degreased. I'm using a magnet so that I don't lose the small parts, and then I'll show you how to get these things apart and continue forward. I'm going to do all of the intake lifters first, because I'm not sure if there's any subtle differences to the lifter assembly itself inside the exhaust lifters. I imagine they're the same, but I don't want to take any chances and mix up parts. So I'm going to disassemble all of the intake lifters and get those all soaking and degreasing, and I'll leave them for a couple hours, and then I'll come back and do the exhaust lifters. So yeah, let me get these soaking, and then I'll show you how to disassemble a lifter. So all I'm going to do is make sure that these are kind of sucked up to my magnet. in a decent way where they're not going to get lost. I'll just swish them around in the degreaser for a little bit. I've already sprayed off these lifters before I disassembled them with brake clean, just to get the ATF off, because I had them soaking in ATF, if you guys saw that other video. Because the ATF is a detergent oil and it kind of helps clean things. So while they were sitting, I figured might as well just put them in something that's going to help kind of get the gunk off of them. So basically I'm just getting the whatever engine oil's left on them off, and then the ATF that I had soaked them in. Just rinse them off in some soapy water. Get the degreaser off. And then I'm basically just going to drop them into this this varnish remover, Berryman's varnish remover. This magnet's a little strong. I'm a little worried about getting this tiny spring off of there. Not a problem. Doesn't have a lot of surface area, so it doesn't stick real good. But yeah, so there's that. I'm going to degrease these separately, the lifter bodies. But basically, I'm going to move my camera so I don't upset all this stuff when I'm getting these apart, because it's kind of a violent thing. But I'll show you how to take the lifters apart. Okay, so basically the lifter assembly has this plunger inside, and that's what houses that whole check valve assembly, that lifter in there. And they have like a little spring-loaded detent clip on them, and basically you can try to grab them with pliers and kind of pry them apart, but the easiest way to get them apart is just to find a hard surface and just slap them on it with the lifter side down. And they should pop right out. Then to get this lifter assembly apart, you just pull this piece out. So that's the lifter, this is the check valve assembly, and this is the little spring that helps it pump itself up. So that's the three main parts. And then this check valve assembly, this is the little clip right here that you need to pry out, and it comes out pretty easy. So you can just grab it with some pliers, just on that little nipple there, and just kind of wiggle it out. But be very careful, because that little tiny spring and ball are in there. So there's the ball, and the spring's inside the little top hat there. But it's very, very, very small. So small that the oil keeps it from falling out. So there's the spring. I don't know if you can see that. It won't probably focus. But it's tiny, and you don't be very, very careful not to lose it. So if that kind of puts it in perspective. Way smaller than my finger. So being very, very careful not to lose these pieces. And you know, how you guys get these clean is kind of up to you before the varnish remover, but the varnish remover is what really does the work. You definitely want to degrease them beforehand, but yeah, that varnish remover works awesome. So I'm going to go ahead and pick all these up again, and then do the degreaser, and then soapy water, get the degreaser off. And if you want, you guys can do these one at a time, like set up a bunch of little plastic cups or something, and keep them all separate. But I'm pretty confident that all the parts are the same, and at least for the intakes, all the intakes, and then all the exhausts. But careful how you grab this spring so that you don't bend it up or anything. But yeah, and then I'm just going to let it soak in this Berryman's varnish remover. So that's basically all there is to it. The assembly process is basically just backwards of that. So I'm going to go ahead and keep going on these, and like I said, do all the intakes at once, and then I'm going to do all the exhausts at once, and then I'll show you cleaning them up after they've soaked, and then we'll go back through the assembly procedure. As far as the bodies, I'm just probably going to hose them off really good with like some brake clean, and then I'm going to drop them in that bucket of varnish remover, and then just to get all the oil off. So I'm going to keep working on that, and we'll be back. Alright guys, so while I'm waiting for those lifters to soak in the varnish remover, I got some time to kill, so I'm going to get started on thinking about how we're going to do this crank pulley, so the lower timing gear that hooks to the crankshaft, how to pin that, and in a way where it's going to end up, you know, lining up and working nice. So let's do that. I got to get this mill cleaned off behind me, and I also tried to press something with it the other day, and the head moved a little bit. So I have to tram in, I have to sweep in the table to get the head straight, and then I'm going to show you how to tram in a vise while I'm at it. I think this one's already straight, but double check it. Anyway. So I'm pulling the chuck and the tool out that I just used, or the collet I should say. And to get this head straight, you basically want to sweep the table in to see if the table's level in a kind of a circular motion. So I'm going to wheel this table over out of the way so the vise is out of the way. And what you're going to need for this is a dial indicator and a way to hold that indicator in the spindle or on the spindle. I use what's called an indical, which is this guy here. So this is a little indicator holder. It's got a bunch of tension screws, and then this clamp part right here is made to fit around the spindle of a standard mill. And then this last little deal here is made to hold in the dovetails on an indicator. So we can put an indicator in there, and it's kind of hard to do while floating in midair. So you mount your indicator in there on the dovetails, and then we'll mount this onto the spindle, and then we'll sweep it in on that table to see if it's level in all directions with the table. This isn't necessary if you're using like a drill press or something. Although if you do have a drill press with a tilting table, this is a good technique to at least know how to do in case the thing's crooked and you're trying to get it dead level. This is how you do that. So this guy is going to go right on the spindle, and then we're going to kind of eyeball the center of the table here. Unlock the table. I'm going to eyeball the center of the table with the center, basically T slot there, and then I'm going to get it over here where it's kind of out of the way of everything. And then I'm going to lock this guy down tight so that we're sure it's pressed up against the ways where it's supposed to go. So I'm going to try to get this kind of adjusted where it's still going to stay on the table when I sweep it around. Okay, so I got that pretty much set up where I want it. Let's see what I can do here to hold this camera. Okay, so basically I have the indicator mounted on there, and we're going to sweep this table around, and then we're going to adjust this head. So this is the part that moved where this adjustment is. So when I was pressing it, this thing kind of moved just a smidge. So I just want to double check. I moved it back to 0 on the number, but the number's pretty open. Like if you moved this just like a hair on the number, this sweeping the table in would be way out. So what I'm going to do is just double check it and make sure that it's square to the table. So I'm going to bring the table up until it interfaces with the indicator. So about halfway through the indicator's travel. So I'm touching now. And then basically I'm just going to sweep this around 180 degrees and see how close I am as far as level to the table. And I can already tell it's a few thou out. So that's reading just a little past 0. And on this side, so we're about, according to the indicator, we're about 3 thou out. The indicator is relative to its angle, so it's not exactly 3 thou, probably, but it's close to that. So what I'm going to try to do, I'm going to loosen these lock screws, and I'm going to try to basically just see if I can tap it into place here. That's the wrong direction. So I need to move about half of the distance on the indicator as what the difference was from the front to the back of the table. So I'm going to just snug it up there and see where we're at. Just lightly. So it's still a little off. I guess this one's not really half the distance because the fulcrum point is actually back here. So the fulcrum point's here, so as you're swinging that head up and down, the whole thing's actually getting close to the table. So it's not, if the fulcrum was right in the middle, then you could go half the distance, but that's not really the case here. So I'm going to keep messing with it until I get that square, and then I'll lock it into place. And you know, it could be out in the other direction too, because there's an adjustment there too. So as you're sweeping this, you can kind of sweep it around 180 degrees this way, and then kind of see, you know, this direction on the table, go 180 degrees out from each other in that direction, and see how square it is. So it's within about a half that direction for me, but this direction's still off. So we're about 0 in the back and about a half thou, and a little over a half thou in the front. So we're gonna keep, wrong direction again. So it stopped moving. So there's an adjustment. There's an, let me see here. Where is the adjustment on this one? I think it's this screw back here. So this screw up here it's got like a worm drive set up on it, and basically that's the hard adjustment for it. So I think even though I tapped on it, I think that we're probably up against that worm screw, so it's not moving any farther. So we're going to have to adjust that, and we should be able to tell which way we need to go by which way's got pressure on it. So I can already tell that way had pressure. So I'll just back it off a little bit, and then I'll try to tap it in again. So we're within about a half all the way around now. I'll double check it in this direction. Yep. So that's pretty close. I'm going to snug these up just a little, the lock screws, and then I'm going to double check it again. Yeah, I think that's good. So that's how you sweep in ahead. And if the other direction was out, so that's going front to back. And then there's also these screws that allow it to tilt this way. So same deal. You'd sweep in the table in the X direction, so this way, to get that straight if it was out this way. So that's basically how you sweep in ahead to get it straight. If it was a drill press with an adjustable table, then you would be sweeping in, or you'd be moving the table to try to get the table flat. And it'd be the same kind of deal, you know, get it snug and tap it around with a hammer. So I'm comfortable with that. I'll send the spindle back up, and I'm going to show you how to tram in this vise here. I'm pretty sure it's already straight, but I'll show you how to check it. I'm going to lock this spindle into high gear so it can't move. And so when you're doing this, you're basically just going to sweep in the X direction along your vise jaw. So let me get the table over where it needs to go. So I'm going to just bring that indicator down, and then I'm just going to move the table in the Y direction until it just interfaces and gives me about half my indicator travel. So about there. If you guys could see that needle move, hopefully. So I'm going to lock the Y axis down on this table, and then I'm just going to move it in the X axis, and I'm just going to move it along that vise, and basically the goal is to have that indicator not move at all. So if that needle stays perfectly still and you know it's not at the limits of travel for your indicator, as you sweep it across that vise, then you know the vise is dead straight. So you guys can watch. So it's pretty darn close, so I don't have to mess with it. If it was out, you would loosen these bolts, and usually what I do is I'll loosen them both, and then I'll snug one side up pretty good, and then just snug the other side just barely, just to where it's putting just a smidge of pressure on it, and that way that one bolt ends up being like your fulcrum point that it rotates around. And it makes it a lot easier because that side of the vise won't move as much as the opposite side as you like tap the vise around. So it makes it pretty quick to sweep it in. So yeah, you just basically have it rotate around one bolt and then slide on the other one. And the only reason that doesn't work is if you run out of travel for some reason in the slots where the bolts are. But as long as your bolts are kind of centered up, you're not going to have that issue. So moving on to this pulley, I'm going to, what my plan is I'm going to indicate this center hole in so I know it's on center, and then I'm going to drill 2 holes where I want my pins to be, but I'm going to drill them undersize. And then I'm going to figure out how to hold this on the crank, and I'm going to hand drill using the holes I've already made as a guide. I'm going to hand drill with the same drill diameter into the end of the crank, and then I'm going to ream both of them together. So I'll bring both holes out to size at the same time, basically. And that way a pin should be able to be driven right in there and line up perfectly. And I'll probably do one side, and then I'll drill and ream the other side after it's already locked into place and can't move. But you know, if you guys have a drill press, I think you guys could probably do this on your own, and a hand drill obviously. But I'll keep going here. I'll see if I can mount this camera somewhere where you guys can kind of see what I'm doing. And I'll explain it as I go. So first of all, I want to kind of see, yeah, I'm going to be able to grab this straight across two of the teeth because they seem like they're directly across from each other. Maybe. I guess we could count them and find out how many teeth there exactly is. I'm sure it's an even number because the cam gears have to be divisible or multiplied by 2, I guess. So it should be an even number, but maybe we can go around and count them. So I'm gonna count them and double check. I think maybe this bolt pattern isn't quite square with itself, so it makes the teeth look a little bit funny. But if we count the teeth, we'll know if it's even or not. So I'm gonna do that, and then I'm gonna come back. I'm gonna grab some parallels too, so I can hold this up a little higher. And I'm gonna grab a pen so that I can mark basically where, I guess it marked where this the current keyway kind of lines up, because I'm going to do my holes basically 90 degrees from that keyway. So I need to mark that hole on the other side where I can see it, and then we'll indicate in and drill the holes. Okay, so I marked where I want my holes, and this hole here is the one that lines up with the current keyway. And then we have 26 teeth total, so I figured it was even, and it is. So we can clamp it across two sets of the teeth. I got some parallels here that are about the right height. So what I'm going to do is I'm just going to kind of feel this out and make sure it's square up against that back jaw with the parallels under it. And like I thought, it's going to clamp perfectly against two of the opposite teeth. So that's how I'm going to grab it. If you have like a round chuck or something, it might be a little easier to grab it, but this is what I'm going to do. So I'm just tapping that down so that it's holding those parallels from wiggling, so I know it's flat against them. I'm going to mount this chuck in the spindle. I'll run the table down here. Mount this chuck in the spindle, and then I'm going to grab an edge finder and find the center of that hole. And then I'll probably have to do some measuring and figure out exactly where I want the holes to be. Now I'm obviously going after this because, like a machinist, because I am a machinist. But if you guys are trying to do this with a drill press at home, as long as the holes end up matching the crank, I think you're going to be golden. But I'm going to go ahead and, make it accurate because it's me. And that's what I do. You guys could probably find like a big drill bit or something and kind of rotate it as you find center to find center instead of so it's touching evenly all the right way around. Is maybe spin it backwards to find that center of that hole. But I'm going to go ahead and use an edge finder to indicate in the center of the hole. So this is an edge finder, and what it is it's got this ground surface is a known diameter. They're typically 200 thou, and it's got like a spring-loaded. This is like on a spring, and as it rotates, it'll kind of be wobbling, and then as it finds the edge of your part, you'll see it true up, and then it'll walk off to one side. And as soon as it walks off, it's right at that 100 thou from center. This part isn't going to be as big of a deal because all we're going to do is find one edge, zero it, find the other edge, zero it, and then the same thing in the Y direction. So you don't have to find the edge of a part. But just so you guys know, that's basically how those work. I'm going to use my nicer Starrett one. So I'm setting the indicator or the edge finder down into the hole. I'm going to kind of eyeball center in the X direction, and then I'm going to go and touch the edge in the Y direction. Let's see if I can get this closer for you. So if I knock this off center, you can see it wobbling. As soon as you get up to the edge, it'll true up. See how it stopped looking like it was wobbling? And then as you find the edge, it'll walk off center just a little bit. I don't know if you guys can see that. Maybe when I do the other direction, you'll be able to see it better. So what I'm going to do is, now that I found that edge, I'm just going to zero. I'm going to zero my X and Y axis up here. And if you don't have a digital readout, you'd have to zero your wheels here, your adjustable wheels. So I zeroed that. Now I'm going to go find the other edge. So it just walked off there. And I have 438 thou on my digital readout here in the Y-axis. So I know the center of the hole is half of that. So what is that? That would be 220 minus 1, so 219 is the number I'm going to go to. So I've re-zeroed it there. Now I'm going to go in the X-axis and do the same thing. See it walk off? Zero my X. Then go to the other side. If you hit it too quick there, you might want to back off and do it again. Because as soon as it walks off, you know you're touching the edge. So same number, 438, so 219. And I'm going to go ahead and lock down the X-axis right there and zero my my DRO, digital readout, and then I'm going to get ready to put a drill in this thing. So right now the machine's sitting right at the center of that part. So I'm going to grab some calipers and I'm going to kind of measure the inside diameter and the outside diameter and try to find the center of that land to drill my hole at. So my plan is to use a 187 pin, so a 3/16 pin, which is a pretty standard, easy to find at your local hardware store type dowel pin. And then and I'm going to use 2 of those. So I'm going to end up reaming these out to a larger diameter, basically. So I want to start with a little bit smaller drill. So this is a what number is this? It is a, can't really see it. looks like a, I don't know, maybe a 9/64 or something, but it's 170 thou. So I measure it. So it'll leave me basically 17 thousandths, right around there, for reaming out to finish the hole. So, and I've got 636 on the ID and 1.180 on the OD. So if I'm going to do the math on that, and I'm going to take the OD minus the ID and then divide that number by 2 and add it to the ID to get my offset number. So what did I say it was? 136 or 636 and 1.180. Okay, so doing the math, I think I want to go 771. See what that looks like. Make sure I did that right. Nope, didn't do that right. Still 0. Oh, I forgot to divide it by 2. So 770 divided by 2 is 350, plus 10, so 360. Still not right. So I screwed something up on my math here. Let me go double check. Okay, so what I forgot to do was divide my center diameter in half before I added half of the diameter of the bolt circle I wanted. So the actual number we want to go to is 453. So, right about there. How's that look? Looks pretty centered to me. So, I'm going to go ahead and drill this. I got to move this back. And then I'm going to go to 453 on the other side also. This metal's pretty soft. It acts a lot like cast iron. I think it's like a powdered metal that they press into this shape. So there's one. Now we're going to go to 453 on this side. Alright, so we've got the holes in there. I'm going to pull this out and go see what it looks like on the block. Looks good to me. Okay, so that looks like it's going to work pretty good. So what I'd like to do is try to get under this counterweight on the crank here and kind of clamp this in place with something. Problem is we have some open bearings here with some assembly lube on them that are going to be great for catching metal chips. So I'm tempted to clean up the front cover and put that on first, so that at least any metal chips are stopped by the seal, and anything that falls out is going down this way instead of back into where the bearings are. So I'm going to figure that out. Maybe I'll clean up that front cover and put the seal in it and put that on at least temporarily. And then we'll go forward drilling these. Okay, so here's what I got figured out. I put the cover on to protect the bearings from getting any metal dust in them. I just cleaned this up kind of half-assed for now and left the old seal in it and put it on there. I'm using this vice grip clamp. It's clamped on the other side of the counterweight on the crank, and then kind of clamped towards the center of the pulley so that it makes it sit flat on the snout of the crank there, and it's pretty damn solid. So I've been looking around the shop and all I can find is one dowel pin. So I have a 187 dowel pin by 1 inch long. It is a hardened steel dowel pin. So my options are to just do one today. I think I can do one and then drill and ream for the second one, but I'm going to have to order some more dowel pins. So back with the same drill we used in the mill, I kind of eyeballed the length of the dowel pin, and it basically goes right to the end of the flutes on my little drill. So that's basically the depth I want to go into the crank, maybe just a hair deeper. So what I'm going to do is I'm just going to stick this in the hole that we already drilled, and I'm going to kind of try to find where center is, kind of feel it, and then let me back this engine up to the table so it doesn't roll away. There we go. That's probably better. So I had to mess around with clamps a little bit just to make sure I had enough room to get the drill chuck in here. But got it figured out. It's pretty straightforward. So yeah, again, just find center, kind of wiggle it around, and then kind of find the center of where it moves and try to hold it there as you drill. So this pot metal is not a very good guide. You can see it's kind of wallowing out a little bit. Pretty hard to keep it on center too. So I'm just going to keep going here and see what I end up with. I think it'll still be okay. I can see why these pulleys fail though. That metal is really soft. Alright, I think that's about the depth we need. We'll see how bad I feel about this little pulley. So the next thing I'm going to do is I'm going to take a 3/16 reamer, and I'm just going to chase out that hole. I'm actually going to go knock the tip of this thing off on the belt sander, because that's going to hit the bottom of the hole before the flutes do. So I'm going to go sand that off just a little bit. I'll just stick it in the chuck of my drill and spin it and hit it with the belt sander. Alright, so same deal. We'll line it up the best we can. And with reamers, you want to go pretty slow and just try to let them follow the hole on their own. You can kind of feel it. I think we're at the bottom there. So, we'll pull this clamp off and see what we got. Looks like we have a hole there. So now after looking at this, I probably could have moved that hole out a little bit. Maybe into a little bit farther into the outside diameter there. But it'll work. It's not protruding on the inside, so it's still totally encased in metal. But I think it'll work. I'm going to make sure we're at the bottom here. Feels like it. Let's see how this dowel pin feels. Drops right in. A little looser than I was hoping, but it'll work. And it's right to depth. So, I think 2 of those will probably do it. But I am gonna spin this over and try to drill this other one now. But I am gonna have to order another dowel pin. Another thing you could do is if you wanted to sacrifice a drill, you could dull these flutes, like kind of hit them with like a grinder or a file, just to dull them out so they can't side cut inside that hole. That'd probably help it stay a little straighter and not wallow out the hole. Same depth as we had on the last one. I'm going to go see if I have a little bit undersized reamer, just so that I can hopefully keep this hole a little tighter than the last one. Nope, I got several undersized or oversized, but nothing undersized. So I'm going to keep going with this one, I guess, and just hope for the best here. Kind of try to keep it real straight. That should be it. So I'll have to order another dowel pin, or a box of them, or try to find one at a local parts store, hardware store. But that's about all there is to doing that, and yeah, it's not too big of a deal. I'm going to try to carefully get rid of all this metal dust before I go ahead and see, that one turned out a little tighter. So I think I might just kind of put some Loctite on these and drive them in before I, and let them sit and dry before I put this pulley on for the last time. But yeah, that's about all there is. So I got double pins, and I just used tools that I had here. So a 3/16 reamer and 170 drill, and a drill press or a mill. So not rocket science or anything. So I think you guys could probably pull that off. Yeah. So I'm going to get back to cleaning up those lifters. All right, getting back after these lifters here. I'm going to go ahead and start pulling out all these small parts with a magnet. You're supposed to rinse this stuff off with water. So I'm probably going to I'm just going to give it a real quick rinse. You can already tell how much cleaner these are. They're like shiny. I'm going to give it a quick rinse in the water, and then I'm going to just put them out here. I'm going to separate all the different parts. The big parts I'm going to blow off with air. The little parts I'm going to try to maybe just hose them down with some WD and hope for the best as far as corrosion. Yeah, these things are like spotless, so basically we're going to be ready to put them back together. These little springs are little. And they're really easy to lose, and I don't know, they're scary. They're scary small. So you want to be really careful. The magnet definitely comes in handy because it picks everything up and just holds it. So a lot less chance of losing stuff than just trying to grab it with your fingers. So this isn't distilled water or anything. So what I'm going to do is I'm going to immediately try to dry these and then spray them down with some WD just to make sure they don't corrode. They're all ground surfaces, so they're pretty shiny, and typically a polished surface doesn't corrode real easy, so they shouldn't corrode quickly. but you definitely want to get the moisture off of them just in case. Found it. I was missing a part. It's stuck inside there. So I got 12 of everything. I'm going to kind of grab these big parts in my hand and just kind of blow them out with air, and then I'm just going to kind of roll these around to dry the little parts, and then I'm going to spray everything down with some WD. Alright, so for those of you that don't know, WD-40 stands for Water Displacement 40. And basically the way it got developed was NASA was having issues with ice forming on their rockets, and they wanted a way to displace any moisture that was trying to stick to the rockets so that it wouldn't freeze and cause that icy layer. And so this company, chemical company, WD-40, they developed this formula, Water Displacement 40. And so it works really good as a solvent and a kind of a lubricant, dry lube. But the interesting thing is they never patented the formula, and their reason for that was that basically they knew they were good at what they did. They were so good, in fact, that they didn't think anybody could copy their formula because they wouldn't be able to figure it out. So their idea was, we're not gonna patent it, because if we patent it, we have to write down the formula, and then it's public knowledge. So when that patent eventually runs out, people would be able to copy the formula and reproduce it as as another brand or whatever. So that was in the 60s, I believe. The patent would have ran out 25 years after that, I think, and so they could have been copied at that point. And to this day, they've never been copied. Nobody's ever been able to reproduce WD-40 exactly the same as they have, even though it's not a patented formula. So just kind of an interesting story. But basically, it means water displacement. So if you want to keep parts from, or get the moisture off of parts, really, it's a good thing to use. So I respect them for that, because they're the best in the business, basically, and they knew they were good enough to where nobody could really copy them, at least not with the technology at the time, and apparently not with the technology of our time either, because they still haven't been copied. So kind of I don't know, I think it's a cool story. So I'm going to go into reassembling these things. They're very clean now, just after soaking in the varnish remover by itself. I don't feel any reason to scrub on them or anything. I mean, they're shiny. There's no varnish left on there at all. So I'm going to start reassembling these things. And so basically the backwards of how they came apart. So that's the ball seat for the check valve. So the ball goes there. And then we have that little teeny tiny spring and the little clip that captures it. So let's see what the best way to go about this is. So I think I'm going to drop this little spring in the hat, and then I'm going to drop the ball on top of the spring. And then I'm just going to flip this thing over on top of it. and just click it in, hopefully. This is not going to be easy with my sausage fingers. Sure, a lot of you guys have the same problem. So the little hat clicks in and captures the spring and the ball, and then this spring basically both helps it pump itself up and it holds that hat in permanently, so it's all captured and the spring is holding that little hat in. And then all that just drops into the main body. Just like that. Now we're going to go through later on, we're going to go through and properly pump these up with oil. But basically that's the assembly, and then this will go back inside the bucket with this flat surface facing down. That's what contacts the valve stem. So I'm going to go through and assemble all these, and then I'm going to soak all the exhaust buckets, take those all apart and soak all those, and reassemble those, and then we'll pump these up and drop them in the head. I'm not going to make you guys watch all that because it's pretty tedious and it's going to take forever, but you guys see how it works, and you can see how clean that is after the varnish remover. So basically that's all there is to it. And the only thing that causes these things to fail really is that ball seat being dirty and not being able to seal properly. So I mean, just cleaning them basically renews them. You know, unless like I said, the bucket's actually worn and you know, destroyed in a way, but that's pretty rare. So yep, I'm just going to go through all these, assemble them all, do the same thing with the exhaust buckets, and then we'll be putting them in the head. Okay, last lifter. Little spring, little ball. So I just get it kind of started in there, and then just push it in with a little screwdriver like that. Then the spring, and then the little bucket. And then this will have some pressure on it if your ball valve's working right. So in order to get that to go down, just tap the little ball valve to release the pressure, and then it'll go down up against the spring. So that's about it for all these lifters for now. Before I show you how to pump them up, I got to get this head on this motor. So and to get the head on the motor, I got to figure out the head gasket dowel pin issue. So I'm going to start working on that, and yeah, we'll see what I can figure out. Okay, so here's what I'm doing. I went and stole some dowel pins out of an FSI block that my neighbor had that's just sitting around rusting. They seem to be the right size. So what I'm doing here is I very carefully placed the head gasket where I wanted it, and I put one dowel pin in already, the one that is already in a location where it needs to be, and then I clamped the head gasket down like very, very carefully to make sure it was all centered on the cylinders, and then I used a parallel with a hole in it, And the hole I need to make in this head gasket is right where that hole is. So what I'm going to do is tape up this surface just to keep any metal chips from getting in there. And then I'm going to go through and I'm going to drill and kind of bring this out to size with a little Dremel tool. And then we should have a dowel pin hole that's perfect for in the head gasket for the motor. So I'm going to go ahead and do that. Okay, so first thing I'm going to try to do here is drill up from the bottom, because I can't really tell exactly where the hole is from the top. So just to find the hole, I think I can drill, if I can get close enough to the block here. Stuff's harder than it looks. Alright, got a hole through there. Now I'm going to take my Dremel with this little carbide bit on there, and I'm going to get it down in the hole, and I'm just going to bring it out until it just barely touches the hole in the block. This is nice because it's got a sharp tip on it, so I can start pretty lightly at the top just to figure out where I'm at and just work my way out slowly. So looking up from the bottom with a flashlight, I can tell which way my hole needs to go. Forgot to mention, the main thing I clamped this way is the last thing I want is any chips between the layers of the head gasket, keeping it from seating all the way. So that's why I clamped this plate over here with the hole in it. So hopefully it'll keep those layers sucked together and no chips can get in between them. Okay, got that pretty close. Alright, I think I'm going to drive this dowel pin down in there before I unclamp everything, and then kind of see where I'm at. Just kind of making sure all the chips are off. Head gasket doesn't move at all, so that's good. Looks good. Looks like it's going to line up perfect. So, I'm ready to put some studs in this thing and drop the head on. Alright, so I got my ARP head studs here. Kind of the same deal with the main studs, just lube them up and then kind of snug them into place just a little bit with your Allen wrench, and then we can drop the head on and go forward. Ew, that was gross. Again, being careful not to get any lube in between anything. You're just snugging them up with your Allen wrench. More to just make sure they're seated than anything. You don't want to go real tight, but enough to make sure they're bottomed out. Alright, before I put the head on, I'm going to go ahead and lube the upper threads on these studs, because once the head's in there, you're not going to be able to get any lubrication on these. So all you'd be able to do is lubricate the nut the best as you could, and you really aren't guaranteed to have good lubrication if all you can do is try to lubricate the inside of the nut. Especially as the nut travels down the threads, it's going to lose most of that lubrication on its way down. So you want to make sure you lubricate these before you drop that head on. And this is of course just the ARP lube that they send with your studs and all that. Alright, before you drop your head on, you want to make sure this motor's at TDC, which means cylinder number 1 is at top dead center. These motors are pretty easy because this keyway on the crank is basically pointed straight up. So just make a note of that. You want to make sure you know where the crank is in relation to top dead center, because when you put your cams in, you want to make sure you're putting them in so that as they get pressed down and move the valves aren't going to hit your pistons. So just make a note of that. This one's sitting at TDC now. And I've got everything lubricated, so I'm going to go ahead and drop the head on. Alright, there it is. Alright, so we're ready to put some nuts on this thing and bolt it down. Alright, so these particular nuts take a triple square tool basically. Some of the nuts take this spline drive, which is a Volkswagen specific kind of thing. But these ones in particular take the triple square. And I know that there's a difference in the years. I'm not sure which ones are which, but some of them actually use the triple square on the OE bolts, and the other ones use the spline drive. I think maybe the later cars use the spline drive. But yeah, that's probably a tool you'll have to get. I don't remember what brand this one is. MNXZ. I don't know, just some Taiwan tool. So I'm just going to lubricate these nuts the best I can. I'm probably going to use my Q-tip again. So lubricating the threads and the face where it's going to interface the head. So, yeah. Just kind of using that Q-tip to get it into the threads. So I'm just going to kind of snug these down by hand, just thread them in, and then we'll come back through and torque everything. These Volkswagen head bolts, nuts, whatever, leave a lot to be desired as far as putting surface area on the head, because they're such a small diameter compared to the stud. I don't know if there's a better version of these things out there, but I mean, I guess the seat isn't very big anyway, but maybe somebody's modifying these so that they have a little bit more surface area where it interfaces the head, because these they leave a lot to be desired, I'll put it that way. Most engines have about a 5/8 or 3/4 hardened steel washer that interfaces the head, and this is like barely a 1/2 inch maybe. So, I mean, pressures, even torquing it could deform the head, and then, you know, cylinder pressure and stuff could actually lift the head and deform the aluminum to do it. So, I don't know. That's not awesome, but I mean, I guess it works for a lot of guys. So, I just noticed on this ARP box, it says no tool. So you can probably order these studs with the tool if you don't have it. Got to open a new packet of grease here. I was still working on the one from the main studs, so it goes pretty far, but didn't quite get me through both. Alright, I'm going to go wash my hands and get my torque wrench set up, and then we'll torque this head down. Alright, so ARP supplied us with the sequence and the torque spec. They said 80 foot-pounds in 3 equal steps. So that comes out to some weird number like 26 point something something something. So we're going to go 26, 52, 80, or maybe 53. And I have to actually use 2 different torque wrenches because my big torque wrench doesn't go down to 20 whatever, 26, and this one won't go high enough. So actually it probably would, but I'm not going to strain myself with this short little sucker. So we're going 26 here. In sequence. So here's the sequence for you guys. Blah, blah, blah. So this is looking at the motor this way. Alright, so that's the first step. I'm going to switch torque wrenches. 2, 3. I wait for my compressor to shut off so I can hear the click. Make sure your tool is seated in those nuts. If you're not all the way down, you'll strip them out pretty easy. Alright, now back to the big one on 80 foot-pounds. Alright, that's that. Head's bolted down. Alright, let's go through how to properly pump up these lifters with oil, basically prime them. A syringe would be really good to have right now to fill these up with oil, but I don't have one. So what I'm going to do is hopefully this holds something. I'm going to put a little oil in this little plastic thing I got, so I can get it into the lifter body even more easily, because these things are pretty small. So let me point this down. So what you want to do is, these are spring loaded and then they have that check valve in them. So you want to fill them with oil, and then you basically want them to suck the oil in. So you can put a little bit of pressure on them and then release that check valve, and it'll pull the oil down in there. And basically what you want is a hydraulic tension on them to where you can't really compress them anymore. And the easier way to do this is to kind of grab just the edge with pliers like this, so you can squeeze them down, hit the check valve, and let them go. And just make sure they stay full of oil. Basically just want to get all the air out of them. Now it's solid. See, I can't really compress it anymore. So that means it's full of oil. And basically that's how you prime them, how you pump them up. And then you want to keep them upright. Make sure they're full of oil. And then you can just stick them into the lifter body. It's probably a good idea to throw a little oil inside there. So get some oil in the lifter body, and then you just flip this lifter body over on top of it and install them into the hole, basically. And they do take a little bit of pressure. Might have to kind of knock them on something. I don't have anything handy at the moment. Here, let's see if this works. So there. So now it's in, it's pumped up, and it's ready to drop in the head. But you want to kind of keep them vertical like this, and just stick them right in the head. That way that hydraulic lifter stays full of oil. And then you can just put it in the head. And on that note, I'm all oily now. I got to get some real work done. So I'm going to put this video together as quickly as I can, and get this video together, and then I got to do some work around the shop here. So if you're liking these videos, if you're learning anything, please subscribe. You know, these videos are kind of helping me out as far as my mental well-being. But we're getting close to having this motor totally together, and some funner stuff is coming up here. So I'm gonna start building some things for this thing, and you know, doing some billet parts and some fabricated parts, and solving some problems that the industry thinks they solved, but I don't really like the way they do it. So I'm going to kind of do my own thing like I always do, and see where we get. So yeah, so please subscribe if you're liking these, and I will see you guys